All right. Morning, gentlemen. So we're just going to run through the solution of the question I was given. A few persons were not calculating surface area correctly, and a few persons were not even naming the solid correctly. So we're just going to run through that. Now it says the diagram above shows a solid. The area of the cross-sectional face ABC is 12 centimeters squared. Now, I brought up the issue of a slice of cheese and person selling a slice of cheese at the corner shop. And I was asking how you'd have cut it. So obviously you wouldn't cut the cheese this way because customers coming wouldn't get the same proportion or equal proportion. So the best way to cut the cheese would be to cut it down here. Now they went even further to say the cross-sectional face is ABC, which means they're referring to the area of the triangle right here, and it's actually a right angle triangle. So you're told that the area of ABC, which is this right angle triangle, is 12 centimeters squared. So area of triangle ABC is 12 centimeters squared. Now it's a right angle triangle, so we could have used half times base times height, and when we work this out, we're supposed to get 12 centimeters squared. Now it's half times the base, 6 times the height, which is actually what they're asking us to find, the length of AC for the first part of the question. So in order to calculate the length of H, we just want to make H the subject or transpose for H. Half times 6 is 3. 3 times H equals 12. So H would be equal to 12 over 3. And H would be equal to 4. And the units are centimeter. So we just indicate centimeter there. So this would have been the solution to part 1 of the question, which asks you to find the length of AC. Moving on to part 2. Part 2 says calculate the volume. Now this solid here is a prism, right? It's actually, even though it's sitting on a rectangle, it's actually a triangular based prism because it's turned the wrong way. And the reason why it's a triangular based prism is because the cross-sectional face is a triangle. So it's a triangular based prism. I just turn it this way as opposed to turning it this way. So just be mindful that a lot of persons said pyramid, which means you don't understand the difference between a pyramid and a prism, which should have come out in your research when you look at the definitions of some of the solids that you actually presented on. So this is a prism. Why? Because the sides meet at edges. All the sides meet at edges. A pyramid has the sides or faces meeting at a point. Okay? A prism, the sides or faces meet at edges. So that's the difference, right? And the challenge question I gave about that 1/3 with regards to pyramids, if you had done and made an effort to do that challenge, you would have further understood the difference between prisms and pyramids. All right. So I'm still throwing out that challenge. I hope somebody answer it. Parks, you have been doing very well so far, Diego, in terms of the speed exercise. Oh, by the way, a lot of persons didn't respect time with the speed exercise. So be mindful. Anytime a speed exercise is given, you must respect the time. So if I give you a specific time limit, you must answer the questions within that time frame. That's what a speed exercise is all about. All right, moving on to part 2. Part 2 says to calculate the volume. Now the volume of a prism, once it's a prism, the volume of the prism is always area of base times height or length. When it comes on to a prism, there is no 1/3 involved. It's only involved when it comes on to pyramids. So still do that research about the 1/3. So the area of the base, now the base is triangular. We already have the area of that base, which is 12. So we've already worked that out. So this is 12 centimeters squared, and the height is actually 30. Height is also the length. And if it were standing on this base, then you would see that 30 centimeters is the height. So that's 30 centimeters there. And of course, this will give you 360 cm cubed. So I've answered 2 parts of the question. Now for part 3, which quite a few of you calculated incorrectly, we're asked to find the total surface area. Now this solid here actually has 5 faces. Now we already have the area of this side. Now when you come on to this triangle at the back, it's also the same dimension as this one. The base here is 6, the height here is 4. Let me just put on the 4 centimeter here now. Right, so we have the base and the height. So the area of this face would be 12, and the area of this face would also be 12. So area of both triangles would be equal to, if we got the area, we know the area of the triangle is 12, then this one is 12 as well. So that would be 2 times 12, which is 24 centimeters squared. So we have the area of both triangles. Now, let's look at the rectangle at the back. There is a rectangle at the back right there. Now, the dimension of that rectangle, this is 30. So 30 would come here as well. So 30 centimeters there, and this is already 4. So this would be 30 times 4. So area of a rectangle at back would be equal to length times width, which is equal to 30 times 4, which is 120 centimeters squared. So far we've covered 3 faces because of 2 triangles and a rectangle at the back. Now there's a rectangle lying on the ground right there, if you can see that. And the dimension of that rectangle is 30 by 6. 30 by 6. So area of rectangle on the floor, so to speak. So that would be 30 times 6, which is 180 centimeter squared. Now, that is so far covering 4 faces. Now, there's another face that somebody didn't look at carefully, and that one is a little bit difficult to see. So let me see if I can emphasize that a bit. Oops. Let me see if I can emphasize that a bit. What I'm going to do here is just the rectangle, let's call it BC DE. So there's a slanted rectangle, which is this. There's a slanted rectangle which kind of slants this way, yeah? So it's slanted. So I hope you guys can see that. And that rectangle is BCD. Now we have one length of that rectangle, which is 30 centimeters. However, we don't have this one. But this side of the rectangle is the hypotenuse of this triangle. If you look at it, the length of this side BC of the rectangle, of this rectangle here, which is slanted, this side here is actually the hypotenuse of this right angle triangle. So we need to find that. So assessing slanted rectangle. Okay, so the first thing we need to find is the hypotenuse, which is BC. Hypotenuse BC. Let me just find that. And that's going to be the square root of 6 squared 4. Okay, so that will be 6 squared plus 4 squared. So this will be the square root of 36 plus 16, which is the square root of 52 if I'm not incorrect. So it will be 6 squared. Let me make sure that my calculator is cleared. So this would be 6 squared, which is 36, 4 squared, which is 16, 52, and the square root of 52, I'll just leave it at 7.2 centimeter just for speed. Of course, it is preferred that you use 2 decimal places, but for speed, I'm just working with 1. All right. So we have this length now to be 7.2 centimeters. So the length of that side now. So for the rectangle, so area of slanted rectangle equals 7.2 times 30. And that would be 7.2 times 30. That will give us 216 centimeters squared. So what do we have now? We have, quickly, we have the area of the 2 triangles. We have the area of the rectangle at the back. We have the area of the rectangle on the floor. And finally, we have the area of the slanted rectangle. So we're just going to add those values together. So to get the total surface area. So the total surface area is going to be 24 plus 120 plus 180 plus 216. And that gives us a total surface area of 500 centimeter squared. That's the total surface area of the solid, 540 centimeters squared. Okay, and for the last part of the question, name the solid. The solid is a triangular based prism. Triangular based prism. And that would have been the total solution to the question. Okay, so I hope you found this video insightful, and I'll see you guys on the next video.